Hi everybody, welcome back to the channel. In this video, we're going to be going through a bunch of hybridization questions. We'll start off with some easier questions and then we'll work our way up to the more challenging problems and also do some trick questions. So with that, let's get to hybridizing. But before we get to hybridizing, I have a quick side note. I wrote the questions with all the atoms shown rather than in bond line form, just in case at this stage you aren't 100% comfortable with bond line. But if there are any requests in the comments, I'll gladly make more practice questions in bond line form, so just let me know. Okay, so the instructions are to determine the hybridization for all atoms indicated, so all the ones with an arrow. If you'd like to try these on your own, feel free to pause the video, but otherwise, let's go through them. So, remember, the most simple way we can determine hybridization is by looking at the number of groups attached to the atom in question. So, if you have 4 groups, it's going to be sp3. If you have 3 groups, it's going to be sp2. And if you have 2 groups, it's going to be sp. Now, as a reminder, a group can be one of two things. It can either be a lone pair of electrons, or it can be anything bonded to the atom indicated. So for the first question, this carbon, which is the atom being indicated, doesn't have any lone pairs, but it is bonded to 1, 2, 3, 4 things. And each one of those things is a group. So 4 groups, that gives us sp3. Now for the second question, it's very similar. The carbon indicated has no lone pairs, but it is bonded to 1, 2, 3 things. So there are 3 groups, that gives us sp2. And for the third question, the same thing, right? This carbon has no lone pairs, but it is bonded to 2 things. So 2 groups, that gives us sp. Now hopefully those questions and their explanations made sense. Now it's time to level up. Okay, so here are the next questions we're going to do. Pause the video if you'd like to try these questions on your own. Otherwise, let's start going through them. Okay, so for the first question, we see that the atom indicated has a lone pair. Now remember, lone pairs are also considered groups. So we see it has a lone pair, and then it's also bonded to 3 things. So the 3 things plus the lone pair, that gives us a total of 4 groups, and so we have sp3. For the second question, the oxygen has 2 lone pairs, and it's bonded to 2 things. So the 2 things it's bonded to, plus the 2 lone pairs, that will give us 4 groups in total, and so we get sp3 here too. And now we're leveling up. Okay, new questions. Pause the video if you'd like to try these on your own, otherwise let's go through them. So for the first question, we have a carbon with a full positive charge. There's no lone pairs as you can see, but it is bonded to 3 things. So we have 3 groups, that gives us sp2. Oh, also as a side note, a carbon with a full positive charge is called a carbocation. Okay, just to let you know that. Now for the second question, we have a carbon with a full negative charge. Notice that there is a lone pair, and then we have 3 things bonded to the carbon. So the 1 lone pair plus the 3 things, that gives us a total of 4 groups, and so we get sp3. And also as a side note, a carbon with a full negative charge is called a carbanion. And now for the third question, we have a carbon with an unpaired electron. And now some of you may be tempted to count that single unpaired electron as a group, but remember, only lone pairs and things bonded to the indicated atom are considered groups. A single unpaired electron is not a group. So, skip the single electron and we have 1, 2, 3 things bonded. That gives us 3 groups, and so we get sp2. And with that, we're leveling up. So here's the final question I'm going to walk through with all of you today. Feel free to pause the video if you want to give it a shot. Otherwise, let's get started. So remember how I said we'd go through some more challenging and trickier questions? Well, here's that question. When you first see this question, you might just think, oh, we have a nitrogen, it has a lone pair, and it's bonded to 3 things, so the 3 things plus the lone pair, that should give us 4 groups, and so the nitrogen should be sp3 hybridized. But that just ain't it. So notice how we can actually draw a reasonable resonance structure. And in this resonance structure, nitrogen no longer has a lone pair, but it's bonded to 3 things. So that gives us a total of 3 groups, and we get sp2, which is our final and correct answer. So you might be wondering, so why wasn't it sp3? And here's the general rule. If you can draw a resonance structure, and you have to choose between 2 hybridizations, the correct hybridization will always be the one with less p in it. Okay, that sounded really weird. Let me re-explain. So for this example, our first structure gave us sp3, and our second structure gave us sp2. sp2 has less p in it, right? Because 2 is smaller than 3, right? Okay, so the correct hybridization should be sp2. Thank you all so much for watching. I hope this video was helpful. If you have any questions, comments, or concerns, feel free to leave it in the comments, and I'll be sure to answer them. Great job, everybody. Good luck. You got this.